piecewise and differentiable, then always it can be produced, which is the case here. Now let's look at the last part. So determine the Fourier series in the form of this. So we want to write or rewrite what we have here in the form of harmonic oscillation, the one you can see there. So we go to part number 4 now. So again, I think this part is not very difficult or time consuming because we have the general shape or formula. So we need to write it in the form of A0 plus the summation of AN cosine of N omega 0 T plus phi and here it's only the positive range, the one which is asked for. What is A0? Can you remember it from last time? Yes, please?
C0?
It is C0. So we have it. And I think it was 1/3. Am I right?
Yeah, yes.
So we have it. What is AN? Yes, please?
CN.
Is it CN? Or is it absolute value of CN? Yes, please?
It's 2 times the absolute value of
It is
CN.
2 times absolute value of CN, exactly. So AN is always 2 times absolute value of CN. Which it's possible to obtain it. Why? Because we have the CN formula. We can multiply by 2 and take the absolute value, which it will become 4 over N2 pi 2. And we need to also find phi of n, which, as you know, is the argument of Cn. And for n equals to 0, C0 is 1/3. What is the argument of 1/3? Can you remember it? Last time we talked about it. So argument, it means always an angle. And I want to find the angle of 1/3, which is the positive number. So I will be always in this part of the axis, maybe here. What is the argument for this? Yes, please.
0.
0, exactly. So here is 0. So if n is even or f is odd, let's see what we get. Let's assume I put n equals to 2. If I put 2 in this formula, n is 2. So this one becomes plus 1 because the multiplication to the even number is not minus 1 to the power of even number is always plus 1. And here I have again 2 to the power of 2, which is 4. 2 is a positive number, positive, and also this is a positive. So at the end, this would be always and always some positive number. Are we all agree with it for n equals to 2? So again, I will be somewhere here. I don't know the exact number, but somewhere here. What is the argument for it then? Yes, please.
0.
0. Actually, for all even numbers, if you try, it will become 0 as well. Now let's look at for odd number, like, I don't know, 1. So this would be always minus 1. But here would be always and always, no matter what is the value of n positive, because it's the power of 2. Some positive number times minus 1 make it negative number. So for n equals to odd number, now I will be always in this part. So maybe I'm here general as it is. So here you don't need to substitute what you have there here. Just keep it as a phi n. And then you have the answer. So if you want to do everything manually, the most time-consuming part is when you obtain the CNs. Yes, please.
What did you? That's the amplitude.
Is no, this is the phase spectrum, phi n.
Phase spectrum.
That was phase spectrum.
Okay.
If you remember it from last time. Okay. Now, any question for example number 1? Yes, please.
Is that the result?
Yes, the last line is the result. Is it everything clear? Please ask which part is not clear. Yes, please.
The thing I'm confused about is when n is not an even number, how do you know that it's pi of phi?
Okay, here, if n, when we consider odd and even number, you should try to obtain it for multiple numbers and see how does it look like, okay? Assume n is a odd number and n is 1. Just as an example, n is 1. If I put n equals to 1, this is 1 because it's a 1 to the power of 2 times pi to the power of 2. So here I have pi to the power of 2 as a result. So I have 2 over pi to the power of 2, then minus 1 to the power of 1. Okay? I just used the formula and I put n equals to 1 in it. So the result you get here would be always and always the negative number. Okay? So if this is the axis you have, this is the positive part of axis, this is the negative part. So you will be always in this negative part. Am I right?
Yes.
Always. Your cross is sitting somewhere here. Now, you want to find the argument. For finding the argument, which is always, the result is the angle, we use this cosine axis or this line as a reference point, and we turn anti-clockwise. So we have to turn here. In order to reach to this part of axis, I have to turn pi degree. And that's why for n equals to 1, it will become pi.
And then when n is even, then it remains on the right side. And then
Always
it's 0.
you get some number which is here. And if I want to move this chart from here, I don't need to go anywhere because I'm in the same, this chart shouldn't move because the angle is 0 here. Because I'm in this positive part. Yes.
But how did you get 2 with an equals 2?
This is how an is defined. You have seen it last week. It
Yeah,
was in the
okay.
lecture slides.
Okay. Yeah.
So always and always, an is 2 times absolute value of Cn.
Okay.
So if you back to the last week lecture, I think maybe I have it somewhere. Let me, I can show you. Where was it? It's here.
Okay. Yes.
But A0 is always C0 and AN is always 2 times Cn.
Okay.
Absolute value of Cn, sorry. So that's why. Let's go to the second example for today. So I erased that was the end of first example. And this is board number 5.
Miriam,
Yes.
where did n multiplied by omega 0 times t t plus phi n. Where did omega go?
Doesn't it's there? Where was it? I should go one slide back. Okay. Here, you can see the cosine is also there. Cosine of n, your omega 0 was pi. I just wrote it as a pi times t plus phi n. It is there.
Okay, so omega is pi.
Omega 0 is pi in this case. You can see, let's back to the last week's slide. Here, the formula is omega, and omega is the basic ground gradient frequency we obtained earlier for the exercise, and it was pi. That's why here in the solution, when we look at the solution, I have cosine of n pi t. So it is there,
Okay,
but I just replaced it with pi.
okay.
Yeah.
Yes, because we got told that omega is equal to pi times t, which was equal to pi. And
No,
that's
the
why-
omega, if you remember, basic omega was 2 pi divided by capital T.
Yeah,
and T was 2,
Yeah.
so it is 2 pi divided by 2, which is pi.
And that's why you can switch it out with.
That's why I replaced it there.
Okay, perfect.
Okay. So we are in the board number 6 and example number 2. So let's look at example number 2. So for the function t to the power of 2, so the function is the same as before. We have two periodic functions, t to the power of 2 for the range of -1. We need to find the middle effect or mean effect. So I will move this because I don't want to see or look at it for now. So I want to find the mean effect of this function. And we have a formula for mean effect. Again, can you remember it from last week? I think I can show you also the slides.
No, I don't remember.
It is here. Again, I think it was end of the lecture. Is it this one? No, this one. So, the mean effect is this formula, or we can say this one. So I will use this one. So I call capital PF.
But what was the mean effect?
The mean, it comes from the average. So if you use this formula and find the mean effect of your signal, then you will have the average. How is the average of your signal in a time? In time.
Okay.
So again, if you can't remember, just go and look at the slides. It's there. So I use this one now. T is 2, so I will use, or I will write it as 1 over 2. The integral of -1 to 1 of absolute value of f of t, which in this case is t2. Alright. Then to the power of 2. Then dt. Yes. So now we need to solve this integration. And the good thing about this function here is that t to the power of 2 is always positive. So we know the shape is always this shape. So we don't have a negative number here. And absolute value of it is the same as the function itself. So I can write it as half of -1 to 1 of t to the power of 2 to the power of 2 dt. So you can see I could get rid of apps now. t to the power of 2 function. We know the shape is this one. And as you can see, this f of t equals to t2 would be always and always in a positive y.
Yeah.
So absolute value of positive number is also always itself, nothing will change. So for instance, the absolute value of 5 is always 5. So it will not change. So the absolute value of t2 is the same as t2, and that's why I could get rid of abs notation here. And then now I have t to the power of 4, so it will become this. Which part is not clear?
The last part we say at that. What did you say?
Okay, I will say. Okay. Are you agree that t to the power of 2 is always and always positive? It's
Yes.
always positive number.
Yes.
The absolute value of positive number is always the positive number itself. Positive number itself. Like absolute value of 5. What is the absolute value of 5?
5.
It's 5. Okay? So, based on this, we know
Okay. Yes. That's why you can. Say
that's why I can remove this absolute value
because
now.
it's-
Yeah. Okay. Any other question here? Yes, please.
I'm just wondering because there's an alternative. I can't remember the condition that you have to use.
You
the
mean
f of t.
this one?
Yeah.
Okay. If your function f is not a real function, it's complex, you have imaginary there, then this absolute to the power of 2 is equals to f of t times f of t complex conjugate. Then you can use that one. Yes.
What if the function was t to the power of 3?
I will explain it in 2 minutes. Don't worry. Because I know that in exercises you have that scenario.
Alright.
Okay. Any other question? Okay. Now, this is the integration of t to the power of 4. It's not difficult to do. Or you can use the integration table. Based on that, it will become t to the power of 5 divided by 5. And then we obtain it from -1 to 1.
Where did you get 5?
The integration of x to the power of n x. So just I will keep it here. This is the formula. That's why. So it will become half. First I put 1 there, so 1 over 5 minus, when I put -1 there, which is 2 over 5. At the end, the mean effect is 1 over 5. And this is the answer for this part. So if I go there, I think we have it there. Yes, it is 1 over 5. No, this one, where is it? 2? Here, 1 over 5. Yes, please.
You have a function where half of the function is negative.
I will explain it now. Just give me a second. Okay. Again, now it's an explanation. Extra explanation is not a part of the exercise anymore. So I will use this one. Okay, now let's have extra explanation or extra example. Let's assume I have a function f of t, which is the same as t, is equals to t, for the range of t and t between 1 and -1. So if I want to plot it for 3 periods, or even for 1 for now, -1, 1, and then if I want to effect of it. So I want to obtain PF. So again, it's 1 over 2, the integral of minus 1 to 1 of absolute value of t to the power of 2 dt. This is the case which we have both negative and minus. Why? Because here is a negative and this is positive. In these scenarios, always and always you have to open the integration to 2 parts. So what I mean by that? So this is equals to 1 over 2, the integral of minus 1 to 1 of something to the power of 2 dt. I will fill out this in a minus 1 to 0, of course, plus integral of 0 to 1 of okay. So for the negative range, the function t is this one, which is negative. The absolute value of negative function becomes positive. Am I right? Why? Because if I want to plot the absolute value of this, it is something like this. This is the pink one. Am I right? So negative becomes positive. So now, here I should write it as a minus t, and here as a plus t.
But why writing it? Yes.
And again, of course, you can solve it and have the final answer. But in a case when it's not like this one, which the absolute values goes away, you always have to open the integration to 2 parts, negative part and positive parts, and do something like what I did here. I'm not solve this anymore, but I think it's easy to do that. Yes, please.
I'm just because when you're squaring the t, it doesn't really matter if it's a plus or minus t.
Yeah, but anyway, you have to do it because in this case it doesn't matter. But if it is in some cases it does.
Yeah.
That's why it's good to do it from beginning to avoid any mistakes later. In this particular case, you are right because it is positive and positive is the same. Okay. Let's go to the next example. This example is something new. You have not seen it before. Okay. Again, we have the same function as before. T2, which is periodic from minus 1 to 1. And we just obtained the Fourier series, and we know that this we obtained it before the break. And we know the mean effect of this function is 1 over 5. Now it says that determine the minimum capital N, which is a positive integer, for which the mean effect of the final signal, which is this is the expression for the final signal, make up to minimum 99% of PF. What is PF? This is what we just got here. It is 1 over 5. Let me see. Yeah. So, always, if you see such a thing in an exam, you either got this in a previous part or it's given to you. And also this final, Fn, will also be given to you, this Fn. So we need to find at what end the mean effect of such a formulation will make up to 99% of PF.
What? 99%?
Of the mean effect.
What does that mean?
You know, this one, which we got, this mean effect is the mean effect of the whole signal for the whole range of minus 1, not minus 1, minus infinity to plus infinity, okay? Now, because you can see we have the whole range here, also here. But now it says that, for now, let's assume we have a signal which we call it final signal. And the final signal has another formulation. It's very similar to previous one, but the only difference is that it's not from minus infinity to plus infinity anymore. It's from minus n to plus n. That's why it's called final signal or something else.
So it's just like an
The
interval.
difference between this formula and the Fourier series we have it, or we could got it earlier, is this range. You can see it's minus n to plus n, and in the previous slide is from minus infinity to plus infinity. So the only difference between the two equations are here. Yes.
So it's an interval instead of infinity.
Yes, because here, for instance, let's a very simple example for the cosine function. The cosine function, we know it's something like this, and it goes forever from minus infinity to plus infinity. Okay? Such a function is a periodic, so we can write it as a Fourier series, something like this, with different numbers. But this summation would be from minus infinity to plus infinity, because it will be for the whole range of t. But now it will say that let's take only one specific range, from minus capital N to plus capital N. It can be anywhere, but let's say from here to here. And this is just for example, but to show you. So now I don't have the whole minus infinity to plus infinity. I have only one specific area.
That makes sense.
If we have one specific area, let's call it final Fn. And then you can see the formula is the same, but the range of summation is changed from minus infinity to plus infinity to what's called minus n to plus n. Okay? Now we should find the n, which gives us the mean effect for this range up to 99% of the mean of the whole range. Does it make sense?
Yes.
If it's not, let me know. So because the mean or the average of the signal for here, of course, is different than when you have the whole range. But we want to find at what n this average can make up to 99% of the first signal. Okay.
Oh, I thought I understood it, but
No problem.
the last thing, you said 99%, so you want the whole, like, take the sinus, so the whole is 100% or what?
No, for the whole of the signal, we obtain the mean effect.
Yes.
And in this example we had was 1/5,
Yes.
for instance, okay? Now, instead of looking at the whole interval, we look at one specific area of minus n to plus n, and the mean effect of this is not 100% equals to 1/5 or any other value.
How is not that?
It depends on what number of n. When I solve it, maybe it will become easier
Okay.
to follow. But let's look at the example first.
Yes.
Then I will try to repeat the explanation one more time.
Thank you.
Okay. So, let's see how we can solve such an example. So, we want to find the value of capital N, which gives us the mean effect of this one in a way that is 99% of PF. So, for the first step, we need to find the mean effect of this, the new final signal. And for this part, because I have the formula of final signal in a Fourier series format, I use the Parseval theorem to find the mean effect. Because we had two formulas or two slides last week. Let me show you. So we use this for PF here. But now I want to use another one, which is this one. Why? I can use this because for function capital N, final signal, I have the Fourier series, and when I have this, I can use the Parseval theory to find PF or the mean. 3. I need to erase the board. So here we have f of n, board number 8, and we have this f of n formula. It is given to us, which is 1 over 3 plus 2 over 5 to the power of 2. Okay. So you can see f of n is in a Fourier series representation. So now I use this formula to find the mean effect, which says that the pf, or I call it pn because it's for the final signal, equals to the summation of minus infinity to infinity of absolute value of Cn to the power of 2. Yes?
Integration or
Oh, it should be summation. Yeah.
estimation?
Yeah. Yes, I can see that. Thank you. It should be summation. And I think in a slide I mistakenly put the integration. That's why I can see that. So it should be summation. Highlight this one. Okay. What is C0? Just you should be able to read or identify it by looking at Fn. What is C0? Yes, please.
1 over 3.
Exactly. So 1 over 3 to the power of 2. And this is for C0. Okay. What is Cn for a case when n is not 0? So maybe I can write as a summation of n equals to minus infinity to infinity of n not 0 of something to the power of 2. What is this Cn? Yes, please.
2 over pi squared and times 1 of the thing.
Yes, exactly. So it is 2
This one and the, yeah, and the next.
over pi square times minus 1 to the power of n to the power of 2. Okay. Sorry. So again, but just looking at this, you should be able to identify Cn. So this can be written
was just a question if it's possible to put the brackets together.
So you mean I write it in one line?
No, down when it's 4 over.
Yeah, you can do that. So you can write it as 4 over n4 pi 4.
Yes.
Yeah, okay. Okay, so now I got the mean effect formula for this final signal. Now I want to find at what n values, capital N values, I get this almost equals to 99% of 1 over 5. And let's back to the question formulation. Here it says that capital N is always greater or equal to 0. So I will start for if capital N is 0. And then later on I go for 1, 2, 3 to see which one is the solution. But for now, if capital N is 0. If capital N 0, then I go here. It means that I have to find P0. And P0 in this case is always and always this one. So it would be P0 equals to 1 over 9.
But how do you know it's P0 is always?
You know, P0, it means for a case when n is 0.
Yes.
Okay? And in this formula we had for n0, it is this one.
Where?
Yes.
Where do you put the capital N?
Capital N comes here.
Yeah.
So instead of P capital N, I have P0.
Okay, but in the formula.
Okay, let me show you again something. Let's where is it? Here. Here, which is the Fourier series itself, it's not the final signal. You can see this summation is on a small n. Am I right?
Yes.
Okay. And in the final one, still, we change the notation to capital N, as you can see here, but it is a small n from minus n to n. Okay? So, look at here. It's written here. A small n from minus capital N to plus capital N. Yes, please.
So the capital N goes to the small n.
Yeah,
Right.
when n is 0. Because here you can see if capital N is 0, in this summation you have only one term, which is for n equals to 0, which is not there. It's out here.
Okay.
Does it make sense?
Yeah.
Because in the general formula, this should be also be written inside here, but we don't, because I explained to you that because we don't have this explanation, I brought it out.
Yeah.
So that's why it becomes always the, this number we have here, 1 over 9. And now I have P0. Now I should find what is the portion of P0 with respect to PF. What would be the percentage we get here? So it is 1 over 9 divided by 1 over 5, which would be 5 over 9, which this would be equivalent to 55.5% of this one. So it's not close to 99%, so it's not the answer. Okay. Is it clear, this line? Now let's go for a case. Capital N is equals to 1. If capital N is equals to 1, it means that F1, I should write the P1, sorry. The P1 would be, I should look at this one for now. The P1 minus 1. Minus 1 to the power of 4 is the same as, so I can write it as 2 times 4 over pi to the power of 4. I will explain it if you don't get what I'm doing. Just give me a second. Yes, which would be 0.9193. Okay. So what I did here, it should be plus here as well. So let's go here. Capital N is 1. So it will become 1 over 3 to the power of 2 plus the summation from minus 1 to 1. From minus to 1, it is 2 scenario. Am I right? It is 1 for minus 1, 1 for plus 1. So if I put minus 1 here or maybe here, then this always will become 1. So I have 4 over pi 4. So maybe if I write it this way, that's easier. 4 over pi to the power of 4 plus 4 over pi over 4. 1 for minus 1, another one for plus 1. And this is the number you get. Again, I need to find what's the ratio of P1 with respect to PF, which if we do that, because we got the number, this would be around 96.5%. Still is not 99%. Yes, please.
Question about so when you have n is equal 1, where is the minus 1 in that?
You know, here, let's look at this summation.
Yes.
So Fn is minus 1.
Yeah.
Then here, instead of n, you should put minus 1.
Yes.
So 4 over minus 1 to the power of 4 is plus 1
Yes.
times pi 4. And this is the first term.
Yes.
Then a plus, when we have n is 1, again 4 over 1 to the power of 4, which is again 1, times pi 4. So maybe if I write it here, this corresponds to n equals to minus 1. This is for n equals to plus 1. And this is for n equals to 0.
Perfect.
Now, maybe it's easier.
Yeah, it's clear now.
Let's look at the next one. If n is 2. For n equals to, I think I need to go to the other boards. Can you take a picture of the boards if you have not done it yet for board 5 and 6?
You're in the picture.
Oh, sorry.
Doesn't it have to be 2 now? Does it has to be 1 of the
It is.
3?
Usually, in examples or exercise, I will give you a case which may be maximum in a 3 or 4, you get the answer. Because it will be too long to do it more than that. Yes, please. What's the question? Okay. So let's look at n equals to 2. So if we are in the board number 9, so for n equals to 2. So I need So for capital N equals to 2, you get 99, yes?
So when capital N is 2, you need to use the 2 and the 1 in the
Can you
equation?
repeat it louder?
Okay then. So when capital N is equals to 2,
Yes.
and I can see in the equations you also says that capital N is also equals to 1 or minus 1.
No, you know, when capital N is 2, okay, then in this summation interval, you should consider small n equals to minus 2 to plus 2.
Okay.
So in the range of minus 2 to plus 2, you have 4 cases.
Okay.
Minus 2, minus 1, 1 and 2. And that's why, actually this summation, you can see there, comes from this summation. So
Okay.
always keep this in mind. That's why we have minus 2, minus 1, 1 and 2.
Okay then.
I will stop the lecture for today here. I have few more slides, but I think you should keep it for next time. That's too much.
Thank you.